Hello, welcome to DSA Code Trainer. Today we're gonna see how to solve an easy brute force problem that it's called Captain Flint and Crew Recruitment. Well, basically in this problem they are gonna ask us if we can form this number by adding four numbers in which at least three are nearly prime. Nearly prime means that they can be made by multiplying two prime numbers in which they are different. For example, 6 is a nearly prime number because it can be formed by multiplying 2 and 3, and also 10 because it can be multiplied by 2 by 5, and also can be 14 because it can be 2 by 7. So let's see how we can approach this. At the end we have to form this number by adding four different positives, and three of them must be nearly prime and one may be any other, and the only condition here is that all of the four numbers are going to be different. So let's see how we can solve it. For example, for the 31 we can add 14, 10, 6 and 1 because 14, 10 and 6 are nearly prime and 1 is not, and all of them are different. So let's see how we can solve it. Well, let's take first the first three examples. Okay, so basically what they are telling us is that we have to add A, B and C numbers in which these three are nearly prime, and we are gonna add another number, and this can be any, but it should be different to all of these. So A, it's different to B, it's different to C, and it's different to D. So all of these four numbers are going to be different. So let's say what are the nearly prime numbers. Let's get all of them until 15. So let's check. Okay, first of all, we just want to get the first three prime numbers because we will always add this quantity at least, always, the first three nearly primes. So let's see which are them. 1, it's not a nearly prime. 2, it's a prime. 3, it's a prime. 4 can be made by 2 by 2, but these are not different primes, so it's not. 5 cannot be. 6 can be 2 by 3, so this is our first nearly prime. 7, we cannot form it. 8, we cannot form with 2 primes. 9, we cannot form. 10, it can be 2 by 5, so it's okay. 11, we cannot form. 12, we cannot form. 13, we cannot form. 14, we can form 2 by 7. And 15, we can form 3 by 5. So we are having these four numbers, and well, our first nearly primes are going to 6, 10 and 14, and we're gonna have also the 15 because it can be made that we select 6, 10 and the 15, and here we can form any other that it's not any prime. So in order to satisfy this, that it zooms to the x value, we're gonna always say like, or we add 6, 10, 14, or we add 10, 14 and 15, or we add 14, 6 and 15 and so on. So this is how we're gonna do the brute force, that we will always select three numbers of this, and we are always gonna remove one of them. So because we will always ensure that we have the 3 nearly prime, and we're gonna remove any of them, and we're gonna see if the rest is different to all of that we didn't take. So with this we can solve. For example, the number 31. For the 31, we can say like we can get the 10, the 15, and the 6. So this is going to be 10 plus 15 plus 6. So this is actually gonna be 31, but we are gonna need 4 integers, and since we cannot print 0, since we cannot print 0, what we're gonna do is like we would say like, okay, I'm gonna take 10, I'm gonna take 14, and I'm gonna take 6. So here in this we got 30, and we're gonna add the 1. So what we're gonna do is like we will sum all of this, that the result is 45. And so in case we find the 45, we are just gonna print this result, and in another case we're gonna always remove one of them, and we're gonna verify that we can add the rest that we need without repeating to the nearly one, and otherwise we're gonna just print no. So this is what we are gonna do. We're always gonna take this, we will iterate over if we remove any of them, and what we're just gonna check is that if the rest that we need to form the x is different to the numbers that we select, then we'll print yes, and we print our answer, and otherwise we're gonna print just no. So let's start coding this problem. So I'm gonna use C++, and let's say these numbers are up to 10 to 5, so let's start with this. So let's read the test cases, and then we're gonna read the text. So as we said, we're gonna have our vector, the nearly prime, that is going to be, okay, sorry for that, it's 6, okay, it's 6, it's 10, it's 14, and it's 15. So with this we got the sum. So in case that our x is equal to our sum, and the sum is going to be, okay, 45. We have to, in case this is equal, we're just gonna say okay, yes, so, and we're gonna print 6, 10, 14, and 15, and n. And otherwise what we're gonna do is like we will check if it exists. So to make it faster, we're gonna create a map that has this prime, so this nearly prime, 10 equals to 1, record 14 to 1, and 15 to 1. Okay, so what we're gonna do is that we'll iterate over all of them, and what we are gonna do is like we're gonna have the rest that we're gonna need, that is the sum is that our x minus, and it's gonna be our sum minus nearly prime. So if our rest is greater than 0 and what we need is so let's see if it's not in our record, in record that count rest, if it doesn't exist or if it's the one that we are removing. Then here we're gonna print just yes, and we're gonna print all the ones that we didn't take. So we're just gonna do if j is different to I, then we're gonna print the nearly prime. And here after printing we're gonna print the rest, and we're gonna have a boolean equals to true, and we're gonna break. So in case we didn't find any, we're gonna just print no, we're just gonna print no. Okay, so let's check if this is okay. Okay, so let's check the answer. Okay, so let's submit our code. Okay, please feel free to comment, and we upload all the results in GitHub, so in the comments it's the link. Thank you.